Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 24th, 2025, about 3 days ago. This paper proposes chunk-level group relative policy optimization for text-to-image models and reports, up to about 23% gains in preference alignment, with better image quality to match. The paper is titled Sample by Step, Optimize by Chunk-level GRPO for text-to-image generation, and the implications for model training are quite significant. The method groups consecutive timesteps into coherent chunks and adds an optional weighted sampling scheme, which together address misattributed credit and ignored temporal dynamics. Alright, Figure 1 compares outputs across methods and shows that chunk-level optimization delivers crisper structure, richer lighting, and sharper details. Preference alignment means images match what people tend to like, which often tracks with these visual qualities. The full panel contrasts the base model with Chunk-GRPO and the chunk versions. The left column shows the base model looking flatter. The rightmost column shows weighted sampling, which boosts appeal but can slightly alter structure. That visual comparison set the stage. Figure 2 shows why step-level credit breaks down, because the better final image can still come from a path whose first time step is worse than its competitor. Advantage attribution means how we assign credit for the final reward back to the steps. Group relative policy optimization spreads one advantage across all steps, which overstates good regions and understates bad ones. Chunking fixes this by grouping consecutive steps that act coherently. So Figure 2 showed why step credit misfires. Figure 4 presents how chunk-level training fixes it. The top row samples by step, while the middle row measures temporal dynamics that segment the timeline into coherent chunks. The bottom row then optimizes each chunk with an importance ratio, which compares how likely the chunk is under the new policy versus the old one. An optional weighted sampling scheme prioritizes influential chunks, so training focuses where changes matter most. So Figure 4 presented how chunk-level training fixes it. Table 1 shows preference alignment using HPS version 3 and image reward, which are learned scores that estimate how closely images match human preferences. Compared with Flux and Chunk-GRPO, chunk-level training without weighted sampling reaches about 15.2 on HPS version 3. Adding weighted sampling lifts it to about 15.4 and slightly improves image reward. Okay, Table 2 reports WISE results. WISE is a general-purpose text-to-image benchmark that tests cultural, time, space, and science categories for semantic correctness. Chunk-level training, without weighted sampling, leads the field with an overall score near 0.76. The weighted version slips to about 0.73 because physics and biology lag. Chunk-GRPO posts roughly 0.75 overall. The base Flux model sits around 0.73. Alright. Table 3 summarizes the ablations and shows that temporal dynamics-guided chunking delivers the strongest alignment. Temporal dynamics means using how much intermediate latents change over time to segment steps into coherent chunks. The best score on HPS version 3 is 15.236. That result comes from 17 sampling steps. The chunk sizes are 2, 3, 4, and 7. Without temporal dynamics, the strongest fixed configuration reaches about 15.173. Wrapping up, 2 takeaways stand out. Chunk-level optimization respects temporal dynamics and fixes misattributed credit, delivering sizable gains in preference alignment and image quality, roughly up to the low 20%. Weighted sampling adds punch, but can dent structure on some semantic tests. The broader implication is clear. Segment-wise training may generalize across generative pipelines. That is it for the AI Research Roundup. I am Alex. Thanks for listening.